Start it up. Calc's ready, huh? Come on now, you know this is a big and next unit. Big calc unit. All right. Let's start this off. A little quick review. Area of a circle. Gave it to you day one, and it's on your formula sheet. Pi r squared. And I just remind you of that because you'll see that again in our next formula, which is area of a sector. Before the area formula, what the heck is a sector? Yeah, can you think of it as a piece of pizza or a piece of pie? Sure. Yep, sure. Two radii and an arc that connects it. Okay? And I want to find what's the area inside it. So two radii and an arc that connects it. Here's the formula. I'm going to stop halfway and see if anybody remembers if this formula looks familiar from last unit. So it's the measure of the arc over 360. Anybody remember last unit? That was the start of the formula for, or anybody remember how to finish it too? Circle unit. It was the first couple days. Measure of the arc over 360. If you want to finish it, you can, or if you remember what it was for. Nothing, huh? Will? 7th period knew. Just throwing that out there.
The length of the arc.
There you go. Well, good job, young buck. Yep. That was the start to find the length of the arc, and we finished it off with pi d, which was what? Circumference, right? A part of the circumference. Well, now I'm not on the outside of the circle. I'm in it here. I want to know what part of the, how do you think I'm going to finish this one? Not circumference, but what fraction of the whole thing here inside the circle, and that would be the area. Yep. It's a fraction of the area, a sector. Yep, pi r squared. So there it is. There's your fourth and final formula for the unit. Oh, you want to use it? Yeah, okay. Let's use it. Oh, jeez. God. All right, let's continue on. Sector of a circle, 8 inches, central angle that measures 60 degrees. All right, quick visual. Not that I need one. Central angle comes from the center. That's 60 degrees. Got a radius of 8 inches. How about that sector that is formed there? So we're looking for this area basically right here. What's the area of this sector? Okay, so let's go through our formula right now. Measure of the arc. Now remember, we do have to remember a fact from unit 10, our circle unit. Whatever the central angle is, it's always equal to its arc measure. Remember that one, right? So that's going to be 60 over 360 times pi, radius is 8 squared. Anybody take a look at those multiple choices before I hit up my calculator? Anybody notice anything about them?
They're in
terms of pi. So make sure when you're calculating your answer, let's not hit that pi button on the calculator. Let's leave the pi in our answer and calculate 60 over 360 times 64. I'll see what you have here in a second. Leaving our answer in terms of pi. When you're ready, in terms of pi, what are we looking at here? 27. $30. That's it? Over 3. Everyone get that in their calcs. We're good there. How to leave that in terms of pi? Got to do the full. Just type 60 over 360 times 64. Turn it back into a fraction, you'll get 32 over 3. Any issues? All right, next one here, one of my favorites. We got a competition going on in class, it looks like, and we're trying to find sector COB. So COB, what is the area of this sector right here? And we have 4 kids in class. They're saying this is how I would do it. It looks like 2 are right and 2 are wrong. Which ones are correct? Oh, can we do our period 8 formula first? Forget about Amy, Beth, Carl, and Dex. Can we do a period 8 formula here? What's the measure of the arc first? Let's do our own formula. 24, measure of the arc. Buck 8 over 360 times. Now, I get it. No radius is labeled with a length, but can somebody give me a radius name in that diagram? Give me name a radius. 7? AO. So this could be OA pi. Sorry. Pi times OA squared. Give me another radius in this diagram. There's more than OA. 16? CO, OC. And one more radius in this diagram I could possibly use. 3? OB. Yep. All right, so there's the period 8 version. Let's compare the others here. Amy. Whoa. Right off the bat, 3/10? We have 108 over 360, so does that mean she's automatically wrong? No. Anybody know why 3/10 is all right? Yeah, try it on your calculator. 108 divided by 360 and then turn it back into a fraction. It'll give you 3/10 back. 3/10 is just the reduced version. So far, Amy's okay. Times pi, you're good. Anybody got a problem with BC? What's my issue with BC there? Talk to me. Why is BC incorrect? 23? It's a chord. It's got to be a radius. Amy, embarrassment. Out of honors geometry. Next up, Beth. Maybe short for Bethany. Elizabeth. You never know. She might be part of the E team as well from yesterday. And I still feel bad, Elliot. I forgot it. I still feel bad. I'm sorry. You should have been on the E team. I know you're devastated. All right, 108 over 360. We're good there. Pi, OC, radius? Yep, and we're squaring it. All right, Beth can stay. You still have a place in honors geometry. Carl? I don't know. Carlo, Carlos, might be short for it. 3/10, we talked about that already. Pi. Oh, and look at this snazzy beast here, huh? Taking half of AB. What's AB in this diagram? 10? 22? I just picked 2. All right, 10 and 22. I got it. 5? That's a diameter. Claire, you cut it in half, you get A. Carl's fine. He's showing off, but it's fine, right? He's that kid in class. Dex. Could be Dexter, obviously. I don't know what else. I'm out of ideas there. 108 over 360, good. Pi, good. What's the issue here? What is Dex squaring? 4? The diameter. And even though he's trying to make up for it by taking half of that, you have to square the radius, not the diameter. So Dex, embarrassment, out of honors geometry. We're sticking with Beth and Carl. Okay. You know what? Next year maybe, might be too harsh, but maybe I'll substitute actual students' names in there about how I feel about them. You'll see who's eliminated and good, huh? Maybe next year. All right. Next up. Did it just get significantly hotter in here? Anybody or no? I feel like the temperature just went up like 10 degrees in here. No? Or is it just ladies? Yeah? Okay, I'm not the only one. All right, for some reason. I don't know. All right, good talk. And moving on. I'm telling you the area here. The area is 12 pi. What's angle AOC going to be? I just want to make sure with this problem that you are able to solve it algebraically. I am not concerned that you'll be able to substitute it into the formula. My concern is, can you solve it algebraically? I'm going to start with 12 pi because that's the area of the sector. We're looking for the angle, aka the measure of the arc, so that's why I'm going to put an x there. Over 360 times pi r6 squared. I have all the faith that everyone can pull that off. Can we solve it though? Because you're going to have a few of these problems tonight out of the textbook where you're going to have to solve for x. Well, first, can we talk what's on the left and the right? Anybody see common left and right? What's there? A pi. So whether I do it now or at the end of the problem, they're going to cancel each other out. All right, so let's just get rid of them now. And again, if there's no pi on the left side, it won't cancel on the right. So be aware of that tonight. So right now I got 12 x over 360 times 36. All right, what's your move? Because there's two possible moves next to get rid of the 360 or the 36. What's your move going to be here? Oh, 18? Okay, that's fine. If anybody wanted to divide by 36, you could as well. All right, I'll multiply by 360 to get rid of it. Oh, that's a large number. So I have 36x equals, I'm not even going to try, 4,300. I just can't read the rest of this calculator. I look like a genius there for a second. 4,320.
Yes.
Is anybody breathing? 20, yes.
Yeah.
Divide by 36. So that angle is going to be 120 degrees. And look, that's all I got for you on sectors. There's not much else we can do. What I want to do now is, I love doing this, is taking two figures we've talked about already in this unit, smush them together. What's the total area? Okay, smush them together, and what's the total area? All right, this figure here, what's it made up of? Describe to me what this patio is made up of. Oh, 7. Trapezoid on top. And watch what I'm going to do here, plus a half circle. You can write semicircle, that's fine. And I don't need this. I'm just showing you really detailed step-by-step what's going on. I don't need to see you write that out for credit. All right, what's the area of a trapezoid? Let's start there. Area of a trapezoid formula, 21.
1/2 height times base 1 plus base 2.
Good. Plus half a circle. Circle formula. 17. There you go. Pi r squared. Everything is there for you. There's one small calculation you need to make before plugging everything in. That's it. All right, somebody's going to hook me up with the trapezoid values now. Oh, 12. 1/2. What's the height? 12 wasn't part of it. It was 22 and 10, right? All right, so now I got a third one I got to remember. That's not going to happen. 6. Height? 4. One of the bases? Other base. Plus 1/2 pi. How about the radius of this circle? 9. Thank you, which would be? Great save right there. And lucky for everybody, round to the nearest 1/10 of a foot. Make sure you hit your pi button on this one.
What would you get? 73 point, yeah. Oh, I forgot to. Yeah, I got it.
Oh, yeah.
Yeah, he's not.
No, it's just one half fire square.
No, I didn't. Yeah.
Oh,
Sure.
Yeah.
I put his equation in one half.
Oh.
All right, when you're ready, let me know. Round it to the nearest tenth. 23. 73.3. Yep. All good? One more together here. That's a wipe right there versus slide right. That was not slide right. That was a wipe. All right, how about this figure, huh? Well, I already told you what part of it was. It's not a parallelogram. It's a rhombus, this one. Plus, describe to me what's attached to it. What's attached to this rhombus? 20?
Some semicircles.
How many?
3.
3? So if I put them all together, is everyone all right? I write 1.5 circles. Good, good, good. All right, we haven't talked about this today yet. Rhombus formula from yesterday. 16.
One half times diagonal 1 times diagonal 2.
Okay, good. Plus, we already went over a circle, so I won't ask anybody. 1.5 pi r squared. All right, lucky for us, they give us the diagonal lengths automatically, so it's going to be 1/2 of 24 times 10 plus, ooh, we got to do a little work now for that radius. We have to do a little work. Just so we're clear, we're solving, we could take any of it, but this is what I'm looking for. What is that length right there? But that won't even give us the radius because that's one of the circle. That's my diameter, right? So help me find the side of the rhombus, aka the diameter of a circle. Yesterday we listed a few properties of a rhombus that may help us out. Name one of those properties I can start labeling my diagram with. 22 properties of a rhombus. I should know that. I dropped it. 13.
Diagonals.
Good work. Diagonals perpendicular, so I'm dealing with a right triangle. More properties that are going to help me out. 25.
Oh, what do we have?
We already have diagonals perpendicular.
Oh, the diagonals bisect.
Good. So everyone remember that diagonal of 24. Now it's a 12 and 12. And the diagonal of 10 is a 5 and 5. Looks like I have something in my pocket that I can use here to find that side now. What can I do on that right triangle? 12. Not here. Not here. 5. Pythag. Where should the 12 and 5 go in the Pythag? 15.
At AB.
Good. I'm glad that number popped up, John, because we have something to discuss.
What's that?
Are those crutches really still needed? As I watched you walk down the hallway
They are needed.
without, are they really?
Ask what the doctor said.
Are they really?
Yes.
Okay, because that is number 3 on my top 3 pet peeve list. People who use crutches that don't need them. Because let's be honest right now. I could have came right behind you as you're going down the hallway, just did a one big swipe, and you know what would have happened? John would have kept on walking. No help needed. Just throwing that out there. All right. Number 3 there. That's the top 3. Number 1, it's not even close. Like that's not even number 1, and it happened the other day, and I almost exploded.
What's number 1?
Able-bodied people hitting the handicap button to open up doors. You've seen it. Hopefully you haven't been one of those people. Drives me insane. And then people are like, well, what happens if you have a bunch of boxes and you... No. You have hips, a butt, an elbow, whatever. Use it. All right? Use it to open up the doors. Drives me insane. Drives me nuts. So lazy. Happened here at school the other day. I almost exploded on the student.
You just making
I
that.
swear to God.
And number two, this is going to be controversial. I'm sorry if it offends some people. Pajama pants in public. No.
You wear that all the damn time.
Sweatpants,
Same
fine.
pair of black and
I'll be honest. If you have walked in this class sometime this year with pajama pants, I've thought one of two things. You didn't take life serious today. All right, and I'm not going to take you serious. All right, let's face it. When you see that in public, all right, pajama pants in public. Sorry, sweatpants are fine, but pajama pants, no. You just woke up and you're like, you know what? I'm just going to give up on life today. And wear my pajama pants. All right, no one takes you seriously. Nobody. All right, so there you go. Top three. C. What do we get for our C? Did you tell me the C values?
no.
No? Okay, never mind. I don't want. We're good. You just keep using your crutches even though you don't need them. It is. It's karma. It is. Yep, it's karma. We'll be back. Ooh. I'm not giving up. We'll go right with 100 now. 36. 40. How am I doing over here? 13.
13.
There you go. We have to come up. I have to come up with a name for that.
We did.
No, we didn't.
I thought
What do we call it then?
I don't remember. I feel like there was a name for it. I thought we made something.
Should that also mean like you guys get to guess the next slide transition?
Yeah.
Fine. You're awful at it, so it's fine. Fine with me. So any time remainder of the year, if the answer is the number that's selected, you got it. Okay.
Can we do that?
And I totally put 13 in there, and I didn't need to put 13. Should have been what put in there? And I'm sorry, 6.5. So that's coming up here. 8.
6.5.
6.5. And in all seriousness, now anybody notice the directions? Leave your answer in terms of pi. So there should be a pi in my answer, but we're going to make a lot of you are going to make a mistake here because you're going to plug all that in your calculator except for the pi and leave it there. That's not what should happen here. Watch, and I'll show you why. Rhombus, 1/2 times 24 times 10. That's 120. All set? All right. Plus, I do 1.5 times 6.5 squared. Leave the pi in there. And we should get what? 63.375. Here's why I didn't want you to type it all in your calculator. Can you combine those two? And just slap a pi with it. Can I do 120 plus 63.375 and then slap the pi on there? No, you can't. Why not? Is this number really 63.75? No, it's 63.75 times pi, whatever that is. So you can't add it to 120, all right? Because you'd be combining a number that really isn't here. Okay, this is a totally different number than 63.75. So you guys are staring at your answer in terms of pi. There it is. Okay, you can't, unless the 120 had a pi, then yeah, we could combine them, but it doesn't. All right, questions? Okay, I'm going to warn you, and hopefully you guys can talk within your group when you get to it. Number 4 on the next page is a beast when you get to it. Okay, so you have packet work to do right now, 1 through 4. 4 is a beast. And then once you're done with that, pick up a textbook, please. Let's get working. No drama between other groups. Just focus on your own group.